Hello, welcome back once again. Today we're going to evaluate the integral of x cubed plus 3x minus 5 divided by x squared plus 2x plus 5 dx. So let's get started. For the numerator we have x cubed plus 3x and then minus 5. So this can be rewritten as x multiplied by now following the denominator, so we get x squared here plus 2x plus 5, right? But this equation, they are not yet balanced, right? If you distribute x times x squared, that will give us x cubed, and we have x cubed right over here. Then x times 2x, that will give us 2x squared. We don't have 2x squared at the left hand side, so this shows that we're going to subtract 2x squared here. Then x multiplied by 5, that will give us positive 5x, but at the left hand side we only have positive 3x. It means we're going to subtract 2x, because we know that the positive 5x minus 2x, that will give us 3x. But don't forget, we have a negative 5 here, so it means that from the right hand side we're going to have also a negative sign. So at the numerator we're going to rewrite it in terms of the right hand side. You get the idea? So let's erase some certain things here. So now our integral, which is I, is going to be equal to the integral. So write the numerator as x multiplied by x squared plus 2x plus 5, right? And here you can take away the negative sign, and then you have 2x squared plus 2x plus 5. Then everything divided by, that is x squared plus 2x and then plus 5, and here we have our dx. Now in our next step we're going to split the denominator, right? So here we're going to have I is equal to the integral of x multiplied by x squared plus 2x plus 5, then divided by x squared plus 2x plus 5 dx, and then minus the integral of 2x squared plus 2x plus 5, right, divided by x squared plus 2x plus 5 and then dx. But there's something really cool going on at the left hand side. Did you see that? These both get cancelled, right? So that is interesting. Then therefore our I will be equal to, so here we're going to have the integral of x dx and then minus. Now there's something really nice about this right hand side. 2x squared can be written as x squared plus x squared, and I think we will have a similar expression as the one at the denominator. So this is same as the integral of x squared plus 2x plus 5 and then plus x squared, then divided by x squared plus 2x plus 5 dx. Then all we have to do now is to split the denominator. So here we have I is equal to the integral of x dx is just x squared divided by 2, and then minus, this will be the integral of x squared plus 2x plus 5 divided by x squared plus 2x plus 5 and then dx, by the means of splitting the denominator, right? So this is minus the integral of, we have x squared then divided by x squared plus 2x plus 5 and then we have our dx. So this is really cool for you to know that these both get cancelled, and then we have I is equal to x squared divided by 2 minus the integral of 1, because we have 1 left over here. So the integral of 1 dx will just give us 1 times x, which is just x, right? And then we have minus. Is that minus? Yeah. So here we have minus. But something about this right hand side, right? So here we have minus, and then from here we have minus again, then the integral of x squared then divided by x squared plus 2x and then plus 5. So here we have our dx. So what are we going to do to this part right over here? So what do you think we're going to do? Okay, so I think we're going to write it, right? So this is what we're going to do about that part. So I here is equal to x squared divided by 2 minus x, and then minus, so put this in brackets. So we now have the integral of, so in terms of the denominator, so we're going to have x squared plus 2x plus 5. But for us to achieve this, right, then we need to subtract 2x then with 5. Then everything is divided by x squared plus 2x plus 5, and then we have our dx. Okay, cool. Now splitting the denominator again, and with the negative sign outside, so everything is changing, right? So x squared minus x, then minus the integral of x squared plus 2x plus 5 divided by x squared plus 2x plus 5 dx, right? And then don't forget that here we have negative 2x minus 5, and with this negative sign it will become plus the integral of 2x plus 5, right? And then divided by x squared plus 2x plus 5, and then dx. These both get cancelled again. We're left with 1 there. The integral of 1 with respect to x is x. So this right over here, we just have x. And do not forget, we're going to have minus x, which is negative 2x. Therefore, I is equal to x squared divided by 2, then minus 2x, right? Okay, cool. And then plus, so let's think about this particular place, right? So we can actually rewrite the numerator as 2x plus. So take a look at this denominator here. The derivative will give us 2x plus 2. So if you have 2x plus 2 here, but remember we have plus 5 here. This particular place, there is a plus 5, right? So let me erase it and write it properly. So here we have a plus 5. So we're going to have a plus 3. And then we have divided by x squared plus 2x and then plus 5 and dx. Then we split denominator again. Oh my god, today we keep splitting denominator. What is going on? That's really interesting. So x squared divided by 2 minus 2x and then plus the integral of, so this is 2x plus 2 divided by x squared plus 2x plus 5 dx, and then plus 3 multiplied by 1 over x squared plus 2x plus 5 and then dx. So let's recall this property, this standard integral formula. We know that the integral of f prime of x divided by the function itself dx, that this is equal to the natural log of the function itself plus c. Take a look at this place. The derivative of the denominator will give us the numerator. Therefore, that should be the natural log of the denominator. So we get here x squared divided by 2 minus 2x, and then plus, this is just the natural log of x squared plus 2x plus 5, and then plus 3 times the integral of 1 over. So what do you think about this denominator? So we can rewrite that as x squared plus 2x. Is that 2x? Yeah. So plus 2x plus 1 and then plus 4, then dx, because we know 1 plus 4 will give us 5. And take a look, this right over here is a perfect square, and the 4 right over here is a perfect square as well. This integral is really very interesting, right? But I think the method is interesting. So this is plus the natural log of x squared plus 2x plus 5, and then plus, so this is 3 multiplied by the integral of, so that will give us 1 divided by, so this is x plus 1 whole squared plus, then 4 there is 2 whole squared, and then dx. So we know that the derivative of x plus 1 is 1, right? So then we can just easily make use of this standard property. We have that the integral of 1 over x squared plus a squared dx, this is equal to 1 over a multiplied by the inverse tangent of x over a and then plus c. So using that, then I think we have arrived at the solution. So we have x squared divided by 2 minus 2x plus the natural log of x squared plus 2x plus 5 and then plus, so this is going to be 3 over 2 multiplied by the inverse tangent of this x plus 1 right over here, x plus 1 divided by 2 and then plus c. So this is our solution. If you really enjoyed this video, please kindly support the channel by subscribing. Also like, comment and share.